Good evening, children. Thanks to one mark solution. Why? Because I could something I could deliver to the students. Something I can help to our students. So once again, thank you, Asa sir and one mark solution. Please like, subscribe, and share to your friends, children. So we are going for the case study. The fourth case study of electromagnetic waves. It's a very small chapter, but still questions can be asked. And if any questions are there, you should answer it. So please make a thorough study of NCRT textbook. Please go through it according to the syllabus. Please study. In this chapter, displacement current is not there. So only you have to study about the electromagnetic waves. Let us move on to the spectrum. What is spectrum? Electromagnetic spectrum, you have studied already one spectrum, video, isn't it? When light passes through a prism, you will get the different colors, 7 colors you are getting. That spectrum you have already studied, isn't it? So here we can say that electromagnetic spectrum is a range of all types of electromagnetic radiation. Radiation is energy that travels and spreads out as it goes. Energy means E is equal to h nu. Here we can say E is equal to h nu, and h is the Planck's constant, nu is the frequency. The visible light that comes from a lamp in your house, that means you are getting from your lamp, and the radio waves that come from a radio station are two types of electromagnetic radiation. So the visible light and the radio waves coming from this is examples, just examples we are giving. It is the two types of electromagnetic radiation. The other type of EM means electromagnetic radiation, that make up the electromagnetic spectrum are, which are the ways we can study? Microwaves, infrared, ultraviolet, X-rays, and gamma rays. Microwaves are there, infrared, after that light waves will be there. After that, light waves, then ultraviolet, then X-rays, and then gamma rays. Cosmic rays is also there in this one. Okay. Now let us move on to the first question. You can see again the spectrum is there. It is there. You can just see the spectrum actually. Spectrum means radio waves on the top, then microwaves, then infrared, ultraviolet, X-rays, and gamma rays. The frequency range as well as the wavelength range, both are there. So you can just identify both are there. Only thing, the visible region, all the colors also will be there. That is why this colored one. You can see that colored one is there. Yes, I think you can see that. This is a colored one. So first one, radio waves, you can see the range of wavelength as well as the frequency. So it starts from kilohertz, then megahertz, then gigahertz. It is going like that. So you can see that. Then, so that range if you're studying and the order if you're studying, you will be getting a clear-cut idea. So we have studied microwaves. Microwaves is coming under between radio waves and infrared, right? And X-rays, just now we have studied, it is coming under ultraviolet and gamma rays. Like this question can be asked. Now we can say the classification is roughly based on. The classification is roughly based on what purpose? We can say the first one is, just a minute, okay. First one, it is written wavelength and frequency of waves, then the production and detection of waves, then the way of traveling of waves, then the year discovered. These are the, options given. So which is the option we can say? It's very clearly mentioned there. Which is that option? No doubt at all. The frequency and the wavelength of the waves, which is the, we can say that. Okay. And of course, the production and detection of this. Okay. Classification is, it is arranged in this, and we can call it a spectrum. It is arranged in this manner, wavelength and frequency, and we have classified different classification. We can done it on the basis of the production and the detection of waves. One tabular column is there in your textbook with the bluish color. Usually bluish color you won't look into it, but this one you have to look in. The range is there, wavelength is there, frequency is there, production and detection is also there. Please go through it. Now let us move on to the second question. Which of the following is not an example of EM rays, not an example of electromagnetic rays? The first one we can say radiotherapy. Is it not an example? No. Checking fractures. No, not at all. We know that. Sterilization. That is also we know that. So which is coming under the last one? What is that? Explosives. That is the correct answer. Now, yes, you can see the option D. Now let us move on to the third question. Identify the pair having highest frequency and the highest wavelength of electromagnetic waves. You will get it very clearly from here if you know, if you are going through the electromagnetic spectrum, you will be getting. So we'll just read the options. UV rays, X rays, gamma rays, and microwaves. Gamma rays and radios. Two answers we have to get. First one is highest frequency. That is also there. Then the highest wavelength. Both should be there, isn't it? So what is the highest frequency? Just opposite it will be there, isn't it? So highest frequency we can say gamma rays, and highest wavelength we can say radio waves. You can just, I will just show once again the. Yes, you can see that. From this, it is very clear which is the highest frequency and which is the highest wavelength. So what will be the answer? You can say the answer is gamma rays and the radio waves. Highest frequency is gamma rays, that you can see from there. Then the next one, highest wavelength, that is the radio waves. Now let us move on to the next question. What physical quantity is the same for X-rays of wavelength 10 to 10 meter? That means red light of wavelength 6,800 angstrom, a raised to 0. Actually, we have to write a raised to 0. That is angstrom, 10 raised to minus 9. Here it is 10 raised to minus 10. That is why it is written 10 minus 10 meter, 10 raised to minus 10. 10 raised to minus 10 meter. Then, and radio waves of wavelength 500 meter. So, see, all the rays are given here, X-rays, red light, and radio waves. Question is, which physical quantity is same for all these rays? What are we the wavelength? Wavelength is different, 10 raised to minus 10. And wavelength is 1800 angstrom. Next one, 500 meter. But all these are having the same physical quantity. Which is that physical quantity? That is a very important property of electromagnetic waves. No doubt at all, it is speed. That is velocity in vacuum, we can say C. We will use the letter C, usually velocity of light in vacuum. And its value is 3 into 10 raised to 8 meter per second. No doubt at all. That is the correct option. All of you know that. All should know that, this one. So speed in vacuum, that is the correct answer. Thank you. Thank you, children, for watching. Thank you. Once again, 1 mark solution. Thank you, Asasa.